We have some explanation for that. We have none. Don't worry. Continue your program. Oh boy, it's really something that was fantastic.
Imagine this. You're performing routine repairs outside the space station. Suddenly, your safety cable snaps. There's no explosion, no warning, just a gentle jolt, and suddenly, you're drifting away. 1 meter, 5 meters, 10 meters. You try to grab a hold, but your hand touches nothing. Your colleagues inside the station seem like tiny, ever-shrinking dots. Here, there's no air to carry your voice. You scream, but only you hear it inside your helmet. Welcome to humanity's deepest fear. Absolute silence and all-consuming darkness. Today, we're not just talking about science fiction. We're going to get brutally real. What actually happens to your body and mind when you're actually trapped in space? Will you freeze, burn, or boil from the inside? Let's count down the rest of your life there. Let's start with the worst-case scenario. You're stranded in the vacuum of space without a full suit of life jackets. You won't explode immediately, but what happens is far more terrifying. The moment your body is exposed to the vacuum of space, it feels like a powerful force is yanking all the air out of your lungs. If you try to hold your breath, your lungs will actually burst because the air pressure inside is so much greater than the air outside. But that's just the beginning. Because the air pressure in space is nearly zero, the boiling point of liquids drops drastically. The fluids on your tongue, eyes, and nose will begin to evaporate instantly. You'll experience the strange sensation of your saliva boiling, but not from the heat, it's from physics forcing water molecules to turn into gas. What about temperature? There's no compromise here. If you were facing the sun directly without atmospheric protection, your body would quickly become covered in severe radiation burns. However, if you were floating in the planet's shadow, your body would begin to slowly freeze. The good news? You wouldn't be conscious long enough to experience the full extent of the agony. Without oxygen flowing to your brain, you would lose consciousness in mere seconds. If you weren't rescued immediately, your life would be over in less than 2 minutes. Now, let's change the scenario. You're not floating freely, but you're trapped inside a space station that can't take you home. Perhaps the thrusters are broken, or Earth is experiencing an apocalypse and no rescue mission is coming. What do? The first thing you should be thankful for is technology. There, you don't die immediately because the station has sophisticated systems to manage 3 crucial things: oxygen, water, and food. Did you know that in space, not a single drop of water is wasted? The space station has an extreme water recycling system. Your sweat, the moisture from your breath, and even your urine are collected by machines, filtered, purified, and turned back into incredibly clean drinking water. This water is also the source of your breath. Through a process of electrolysis, the machines break down water into hydrogen and oxygen for you to breathe. As long as the machines are running and you have electricity from solar panels, you can breathe easy, at least for a while. What about food? The station's food reserves are usually enough to last a few months. But if you know help isn't coming anytime soon, you'll have to start drastically saving. You might try gardening in space, growing lettuce or radishes in a small botanical laboratory. However, this is extremely difficult because the extreme environmental conditions make it difficult for plants to grow normally. There's oxygen, there's water. But there's one enemy you can't fight with technology: loneliness. After months trapped inside a giant metal can floating at an altitude of 400 kilometers, you'll start to lose your sanity. There's no sound of wind, no bird song, just the constant hum of life support machinery. Every second, you're haunted by the reality that if even one small piece of machinery fails, for example, the oxygen generator stops working, you'll only have about 3 months' worth of backup oxygen. After that, darkness. Another danger comes from Earth's gravity itself. Space stations must constantly correct their course. If you run out of fuel and become stranded, the station will slowly drift off course and be pulled by Earth's gravity. You'll see Earth growing larger through your window, not as a longed-for home, but as a giant furnace. Your station will plummet and burn up in the atmosphere before it even hits the ground. If the crash scenario doesn't occur, and all resources are exhausted, you'll face a painful final breath. The air inside the station will slowly fill with carbon dioxide from your own respiration. You'll begin to feel dizzy, faint, and eventually die from CO2, poisoning or asphyxiation from lack of oxygen. You'll die silently, millions of miles from the embrace of your loved ones. Is there a way out? Theoretically, there are emergency capsules or lifeboats designed to rescue stranded astronauts. However, to date, many of these systems are still in the testing phase and may not be ready in the event of a real disaster. History records that several astronauts have experienced critical situations on the space station, but fortunately, so far, all have returned safely. But returning home doesn't mean the end of the world. After months in space without gravity, your body undergoes horrific changes. Your bones become brittle, your muscles shrink, and your heart weakens. Once back on Earth, your body must readjust to the incredibly demanding gravity. Many astronauts can't even walk upright for several weeks after returning. Space is both the most beautiful and the most deadly place known to mankind. It offers limitless knowledge, but it comes at a price in the form of unimaginable risks. After hearing all these horror scenarios, I have one question for you. If you had the chance to go there, would you still take the risk to see the stars up close?
We know about that. Could you go the other way? Go back the other way. Well, this guy Riggs should,